Okay, so now we're ready for the next step. And I think at the end of the last video, I was saying next step would be set up the protocol. But as I was sitting around thinking, I think I'm going to go ahead and move this stuff that we checked when troubleshooting the device. And now that the connections on the device all work, I'm going to go ahead and move this to a C++ object. And that way we can just import it and have all of that to work with. Kind of just a naming thing. It might be a little bit of overkill on this project because really it is just we're reading these pins, but I wanted to make sure this project included all the steps of a full, thorough electronics project, and part of that would be making the C++ objects. So let's go ahead and do that. Since the last video I did, in the very last video, there were some typos in the comments. I got the date wrong. It was November 7th, not 17th. The 17th isn't until next week. And what was the other thing? Oh, yes. I'd only put 2 slashes here, so these words down here didn't actually generate into the documentation. Just a couple typos I had fixed since the last video. But let's go ahead and move this stuff, the buttons, and these axis controls over to one single object in C++ that we can just import into this project and then just use an instance of it in this project. And I guess it'll kind of clean up the names. We'll have all of the buttons and joystick under one name. And yeah, but really it's just to show how to put together a C++ file if you haven't seen that before in Arduino. So let's get started with that. So over in Notepad++, we'll need 3 files just to follow good form with C++. Oftentimes we put our declarations in a different file than the definitions. So our first file, I'm just going to go ahead and set these up. So the first file, where am I going here? So under basic control unit and drivers, I'm going to create a new folder to create this, and then I'll import it into Arduino and everything just to kind of go over the steps of how to do this. So what are we going to call this? So this is a basic control unit, so I'm going to call it BCU, well, I'll spell it out. Basic control unit, and then in this folder we'll put our C++ files. So the first file is we need the header file to make all the declarations. So I'm going to call this basic control unit .h for the header file. And then we'll need another file where we write out our methods and actually define our methods. And this one will have the same name, basic control unit, but a different extension. This time we want a .cpp extension. So that's our 2 C++ files, basic control unit.h for the header file, where we make all our declarations, and that is also where we will put the comments for the doxygen, and then we will define the methods in the C++.cpp file. And for the third file, this is for Arduino, we want a file called keywords.txt. So just a text file called keywords. Just a basic text file. And these are all very similar. So similar that I just always copy and paste them and make just a few slight changes. So over on my other screen, I have it open in Notepad so I can copy it over. So this is what the keywords text file looks like. So I can change the name here. So this is now basic control unit. Then under data types keywords, we'll put some words right under this section. And the Arduino IDE will look through, and any words in this section will be orange and bold. Then methods and functions. any words we put, keywords we put in this section will be just orange. Under instances and constants, those will both be blue. I think instances are blue and bold, and constants are just blue. So that's how the IDE knows what colors to make the words, the keywords we define. Whenever we put one in our C++ file, we'll just add it to this list as well. That way it'll recognize them. So now let's get started into the C++. And there's really not that much to do here, just basically what we did here at the beginning. We just need some references to our pins, the buttons and joystick are connected to. But again, this is to kind of show the whole process, and so hopefully it's a simple example to get the process across without getting lost in the details. And we could put these in the same file, but typically it's considered better form to do the declarations in one file and define the methods in another one. So we just need to set up all of this stuff. So we're kind of making a library here. We're defining our class objects, our class to create instances and objects from. So it's like a library, so we'll have to import it. So the first thing we have to put is basically say what we're creating to be imported. I'm not sure where my cursor was there. It wasn't where I thought it was. So to say what we're creating, we don't want to define it if it's already defined. So we'll always start off with this line, if in defined. So if not defined, then we're going to define it. And what are we looking at? So if not defined, the name of the library we're creating. Basic control unit _h. And that's important. Notice the file extension we used a dot, but here in the C++ code we have to use an _h instead of the dot. That will show up in a few places. And if it's not defined, then we're going to define it. Then define basic control unit _h. And then, well, we need to close this if somewhere. So I'm just going to come down a few lines and type end if. Do I need a space in there? I don't need a space in there. Sorry. It didn't look right after I typed it. I was like, oh, I don't need a space there. So if indefined, define it, then the whole definition will go in here. And this is something I always like to point out to students. If you do a lot of looking at examples to learn to code, you're going to be looking at finished products. And that's not exactly the best thing to look at, because we don't think in the same way that a computer processes. You may have noticed a little bit earlier, it's going to show up even more here. I don't start at the top and just continue down line by line and go to the end. I jump back and forth in the way my mind thinks about it. And in the end, it has to be in a certain order for the computer. But I don't think about it in the same order it needs to be in for the computer. So there's a lot of jumping back and forth. And if you always look at examples learning to code and looking at finished examples, you don't see that back and forth and the thought process that goes into it. So just letting you know, there's going to be some jumping back and forth. We're not just going to start at the top and go down. It's going to follow the way my mind works, and my mind doesn't work the same way the computer needs the code to be written in, so we'll be jumping back and forth. So here, we're setting up this library, and what do we need here? We just need one class. So I'm going to throw in the keyword class, and then give it a name, which for this simple case, I'm going to match the name of the file. That does not have to match. We can put lots of classes and different namespaces in here. This does not have to match. The only reason it does in this case is because I wasn't feeling particularly creative and didn't think ahead of time of what a name for this library would be, but I knew I was going to call the object this, so I just called the library that as well. But the class name does not have to match this name. However, this one does have to match the file name. So this thing we're defining has to match the file name, but the classes we put inside of it do not. That's kind of just a coincidence in this case. And then the C++, so we need some curly braces. So I'm going to do an opening curly brace, come down here and do a closing curly brace. And this particular curly brace, the one for the class, does need a semicolon at the end. So class, basic control unit, we start our definition, end our definition, and in this case we do have to have a semicolon. Usually semicolons don't go after curly braces, but sometimes they do. It's the end of instruction character. So end of the instruction of defining a class. So everything that goes in here are the instructions to define the class. So there are two parts we need to set up. Well, at least two parts, possibly a third part, but we'll want a public part, something that's accessible from the outside, and a private part. So we're going to set our data fields to be private, and then we'll access those data fields, get some, really just some getter methods. That's all we need is some variables to hold our pin reference, and then some methods to get those. And so it doesn't get away from me, I'm going to go ahead and put the comments for the documentation generator in here. So again, it'll follow that same pattern. We'll do a multi-line comment that starts with 2 asterisks on the first line. And then whatever we put in here, Doxygen is going to look for keywords and things to generate the documentation. So this is just an overall description of the class. So I'm going to put that in a description section. That section description, and I'll call it summary. And now it just needs a description. The basic control unit class is an object which corresponds to the basic control unit device containing 4 buttons and a 2-axis joystick. So just sort of a description, and I like to make sure I do that along the way so it doesn't get away from me. So now we're ready to put in our public and private components of this class, which basically going to be these same data fields here. We could actually almost copy that over, but I'm going to go ahead and type it in, go over to C++, and then a constructor, possibly an initialization method, and then a bunch of getters for these data fields. And I should probably mention real quick, just in case not everybody's familiar with object-oriented programming, I should probably fix this typo as well. There's an R in description. In case you're not familiar with object-oriented programming, it's often referred to as blueprints. We're creating a blueprint of the thing we'll actually use in our code. In our code, that's an object, so this is the design that our object is going to have. It's almost like what we did earlier with the circuit. We went and drew up the design, that wiring schematic that had the core idea of what we needed, and then, well, I put one example together for testing. But if this idea works out, then send that the blueprint from that wiring schematic off to a factory and order thousands of them to sell for $5 a piece or something. I don't know. But sort of a design thing. So it's a lot like what we did with the physical component. That's just a quick overview of object-oriented programming. And we have certain things that certain concepts we want to follow. There's inheritance, and we won't really be getting into that much, polymorphism. And for this simple example, we only have one thing, so we don't have to worry about objects that inherit all this structure from this design and then expand on it. That's inheritance. Or we don't have to worry about other things that could act like our object, could behave as our object, or our object behaving as something else. That's polymorphism. So an example of it is we're going to have these button values. So we could use this object in another Arduino project to have a button. That's probably a lousy example of it, but that's what's known as polymorphism. The one we are worried about here is called encapsulation, which everything that we need for our controller, which is really what we saw here, we need the variables to hold it, and then we'll need some methods or functions to access the value stored there. We want everything included, enclosed in it, encapsulated. And that's where the private part comes in, because we don't want it to be readily accessible from the outside, almost like protecting our data. So all of these data fields, that's the first part we're going to type, those will be private. So the only place that has access to it is our code. We are the only ones with access to it. You can think of it that way. These files are the only things that have access to the private variables. And the public variables, that is accessible from the outside, anything public. So we'll set all our data fields up as private to kind of protect them. And it'll look just like it does on that other screen there. So we need an int integers to refer to each of our buttons and the access controls. And I'm going to relabel this instead of calling the buttons yellow, red, green, and blue, because that's just the first 4 plastic caps I grabbed out of the box of plastic caps I have for buttons. I'm going to call the buttons A, B, C, and D. And then the x-axis and y-axis, I'm just going to call X and Y. It'll make the naming a lot easier, right? A, B, C, D on the buttons, X, Y for the direction controls. So int A, well, we don't need to say what number it is. So over here where we were testing it, it was hooked up to pin 4, but we're just designing it. We might hook it up to pin 9 next time, for example. So we want to wait until we actually create an object out of our design before we put values into it. We're just designing spots for them to go. Int B, int C, int D, integer called X, and an integer called Y. And these two, A4 and A3, don't really look like integers. So we might need to access the Arduino library in order for some of the stuff we want to do. So we'll need to import that. And to access things in another library, we come up to the top and add this keyword include in. So we want to include another library. And the library we want to include is Arduino.h. And, well, maybe we might need some other ones later, but we're doing an Arduino project, so there's a good chance we're going to need that library, because we wouldn't know what A4 and A3 and A4 are as far as integers without the Arduino library. Those are just constants in the Arduino library that refer to a normal integer. And like we did a moment ago, I'm going to add the Doxygen comments. So the first of the 4 buttons on the controller. And that's basically all of them are going to say that same thing. So Control C to copy, paste, paste, paste. Oops. Put a space in here and then change this to second, third, and fourth. Because we don't know what pins they're going to be hooked up to or what sort of plastic or rubber caps they might have on them come the final version. But we do know there's going to be 4 buttons. So that's all we need in our design is say we have 4 buttons. And then we also have the two controls, the X axis of the joystick and the Y axis of the joystick. And we want to have all this documentation because if this, does turn out well and somebody, a few people use this controller, people like to, a lot of us like to just kind of piddle around with electronics. So some of the people that have this controller might want access to the code so that they can piddle around and make their own personalize it, customize it, try to make their own improvements instead of starting from scratch like we're doing. Just start with that controller and put that together. So those are all the variables we'll need. Just refers to each one of our things, but again, they're all private. So the only way to access them is, well, our code here is the only thing that can access them. So in order to get the values coming in on those pins, we'll need some functions to do that. And we'll make the functions private. And we'll also need at least one constructor to create the actual object of this class, the instance of this class, which is what we call objects.